everyone, my name's Sunchit. I'm 12 years old. Today I'm going to present about plate boundaries and movement. So first let's look at continental drift. So there's a theory called the continental drift theory. So a German scientist thinks of it like he thinks that the earth was one huge continent, one super huge, is more correct. Then it got split out. So why does he think like that? So the first thing is the landmass. So like the height of how the land is like when he thinks of getting every continent and sticking them together like a puzzle, he thinks that it fits perfectly. Second thing, things from this continent exist in other continents, like fossils from North America exist in Antarctica. There. So there's still lots of mysteries at that time. Until today, there are lots of technologies. So yeah, people can easily prove his theory, and his theory is confirmed. Next, we have mid-ocean ridges. So mid-ocean ridges, they are formed because of one thing: movement. The earth has multiple layers. The outer layer, the crust, is always moving, no matter where it is. It's always moving. Those plate tectonics, always moving. That's why there's earthquakes. That's why volcanoes underwater erupt there. And for these mid-ocean ridges, they are actually formed because of these movement, these plate that moves. Next, we have sea floor spreading and trenches. So this is a way that the earth is always shaping itself. So the earth is always at movement. It's slow. This is about the movement on earth, not like the spinning of earth, okay? So yeah, it's always moving, and moving. And you can't feel it until it actually moves so fast that you do feel it, like earthquakes there. And so sea floor spreading is the moment when it's moving under the water, like its name. And sea floor spreading, right? So it's like spreading the sea floor. And so how to spread like the land, the sea floor? The only way is by magma. There's no way else. Like if you're just gonna always stand and pick rocks and throw it down, it's not gonna combine together, except for magma. They stick together before it gets cooled off and become solid. So yeah, so first the tectonic plates are gonna move, and by somehow it's gonna open a hole, and then the magma's gonna get out and then spread out. How? When there's pressure, there's also a trench that's gonna push pressure. So there's gonna be a trench pushing pressure for that magma to go out, but something has to go in too, and that's the old crust. Those old crusts on Earth. It's gonna go into the trench, melt down, and become the magma that will later on be coming back up onto the sea floor and spread out. And do you know that the sea floor spreading actually like occurs on like different ways? So it's gonna spread out more depending on the amount of trenches it have. The more trenches, the faster it's gonna cool off. The faster it's gonna cool off, the less it's gonna spread out. So yeah, it's gonna still pile up there, and then the magma is already cool off before they can like spread out a lot. So yeah. Next we have subduction. Subduction, these are like commonly seen with tectonic plates. When tectonic plates just go down and down. That usually happens at coastal mountain ranges with the ocean nearby. It's gonna push those tectonic plates go down. So it's subduction. There, like its name, going down. There, subduction. And finally, we have the plate tectonics. This should be the first thing I should present about. So these things always moving, and it makes up lots of different things. It makes up the transform boundaries, the convergent boundaries, divergent boundaries, where the tectonic plates would meet and do different things, like the at convergent boundaries are where the tectonic plates smash into each other, move up. That's how hues form. And how about this? Wait, I forgot the name. Destructive. Wait, conservative. Oh, destructive. It's kind of like the name. I can't pronounce it correctly when I forgot how it's spelled. So the tectonic plates are gonna move out. That's how you're gonna like have those hold downs. You fill it with water, it become a lake or maybe a river. And yes, it's gonna go down. How about transform boundaries? You're gonna slide past each other. So they're gonna slide different directions, moving away from each other, but the opposite the way of each other. Look. So these are two tectonic plates. You're gonna slide past each other at a transform boundary. And as you can see, they don't move away opposite each other. They're moving away but sliding past each other. Oh my god. And then there's a lot more with tectonic plates. I cannot get lagged out, but that's all for my presentation. Thank you for your listening and goodbye. 6 time.